So a question is asked, why transformer and alternator are rated in KVA instead of kilowatt? The answer is simple, because alternators or transformers are not load. When we talk about motors or incandescent bulb or any kinds of load which consume electricity, they can be rated in kilowatt, because kilowatt is equal to VI cos phi. So a cos phi element is there in kilowatt, and value of cos phi will depends on nature of load, whether it is a resistive load or inductive load or capacitive load. But in case of alternator or transformer, we don't know which kind of load to be connected to alternator or transformer, because alternator is a generating source, transformer is transmitting power from one source to another source. So we don't know which kind of load to be connected with a transformer or which kind of load to be connected with an alternator. So as a manufacturer, how can I decide power factor of an alternator or transformer, because we don't know what kind of load to be connected with this. For motor it is okay, because we know what is the purpose of this motor, and we can design the motor accordingly, whether induction motor or synchronous motor, so we know the power factor. But in case of alternator or transformer, it is not known to the manufacturer which kind of load to be connected. That's why it is never rated in kilowatt. Another theory is that for a transformer, for example, the total heat loss in a transformer or alternator, that is iron loss or core loss and copper loss, both these two losses does not depend on cos phi, because iron loss or core loss, it depends on voltage, that is hysteresis loss and eddy current loss, it depends on voltage, and copper loss, I square R loss, it depends on current. So togetherly both these losses depends on voltage and current alone. So we can determine the transformer or alternator rating in KVA only, not in kilowatt.